In this video, we're going to explore another tension problem. So let's set up a scenario. We've got two tugboats pulling a ship away from a wharf. The cables attached to the ship are at right angles to each other. The tension forces in the cables are T1 equals 36,500 newtons and T2 equals 98,500 newtons. The mass of the ship is 12 tons and it's accelerating at 0.075 meters per second. We've got to calculate the combined pulling force on the ship, the direction of the combined pulling force is an angle to cable 2, and we're going to calculate the size of the force of the water resisting the motion of the ship using the formula F equals ma. Okay, so let's set up the situation and draw a quick force diagram. So here's my ship. This is my ship that's going to be pulled, and it's pulled by two tugboats, T1 and T2. Now they're at angles to each other. T1 is 36,500 newtons and T2 is 98,500 newtons. They are at right angles to each other. So let's look at solution A. Solution A, I'm going to be determining the combined pulling force on the ship. Well, basically this is going to be a combination of the two pulling forces T1 and T2. They're at right angles to each other as shown in the question. So the T net is basically going to be the pulling force of T1 and T2 on that ship, even though they're at angles to each other. So F net, the net force, will be, using Pythagoras, the square root of T1 squared, 36,500, plus T2 squared, 98,500 squared, which gives me 105,000 newtons to three significant figures. So let's have a look at solution B. In this question, they ask us to work out what the direction is to cable 2. So let's draw a quick diagram again. There's cable 2, and here's my net pulling force. And as it states here, we've got to work out the direction or the angle to cable 2. So it's angle theta. So obviously I can just use SOHCAHTOA here to find angle theta, which is made up of T1 over T2 tan to the negative 1. So theta will basically equal tan to the negative 1 of 36,500 divided by 98,500. When I solve this with the calculator, this gives me 20.3 degrees. So this is 23.3 degrees from the cable 2. So let's look at solution 3. We've now got to calculate the size of the force of the water resisting the motion of the ship using the formula F equals ma. Now the water resistance is basically the friction. So the acceleration of the ship is caused by the total unbalanced force acting upon it. Now this is in the same direction as the net force or the pulling force. So the net pulling force is going to be made up of F equals ma. So this is the total amount of force. The net pulling force is the thing that gets it moving, but we want to find out what is the force that is just responsible for the acceleration. Well, I know the mass is 12,000 times 10 to the 6 kilograms when I convert it. So this is basically going to be made up of 12 times 10 to the 6 times the acceleration, which is 0.075 from the question. This gives me 90,000 newtons. Now I found previously that the combined pulling force of the two tugs was 105,000 newtons, as I've written down here. And basically what that means is that 90,000 newtons is used in accelerating the ship. So where's the rest of the force gone? Well, the rest of the force is going to be directly related to the resistance of the water. So as it says here, the rest of the force is combating friction or water resistance. So because they're acting in the same direction, water resistance is basically going to be made up of the net pulling force, the total of pulling force, minus the force due to acceleration. So the water resistance is going to be made up of 105,045 newtons minus 90,000 newtons, which gives me 15,045 newtons. Thanks for watching.